Good morning, Algebra 2. Here we go with arithmetic sequences. This is chapter 9. We are going to skip the first section, which is just general sequences, but we will talk a little bit about them here. We'll take a look at arithmetic, which is adding, okay, add, and sequences, which is a number of, or a series of numbers that, or a series of figures that are sequenced or have a common factor, I shouldn't use the word factor, but a common characteristic that enables us to go from one to the next, to the next, to the next. Okay, so take a look at these first couple of problem sets. So 2 goes to 4, goes to 8, goes to 16, goes to 32. What do you see there? Okay, they're all even numbers. They're all multiples of 2, yes, and they all double. Okay, in other words, multiply this one by 2 and you get 4. Multiply this one by 2, you get 8. Multiply this one by 2, you get 16. Multiply 16 by 2 and you get 32. So they all double, or times 2. All right? Look at the second one. 5, 10, 15, 20, 25. They're all multiples of 5, yes. But to go from the first to the second, you add 5. And then you add 5. And add 5 and add 5. Okay? So on this one, you're going to add 5 to the previous term. Okay? The third one, you got 5, 5 halves, 5 fourths, 5 eighths, 5 sixteenths, 5 32nds. Notice the 5 on top, the numerator stays the same, but that denominator keeps growing, kind of like these numbers did up here. And on this one, instead of doubling or multiplying by 2, we're going to multiply by 1 over 2. You multiply by a half. Okay? Then you go 1, 3, 7, 15, 31, 63. Okay? And what's happening on this one? Well, if you add 2, add 4, add 8, okay, add 16, you are adding, add 2 would be, you'd be adding a x or a 2 to the x power. So if x is the first term, it'd be 2 to the first power. You added 2. If this is the second term, you added 2 to the second power, so that's 4. 2 to the third power gives you 8. 2 to the fourth power, 16. And then finally the 2 to the fifth power would be adding 32. Okay? So you're adding 2 to the x power. Exponential. That kind of takes us to where we were at last chapter. So arithmetic sequences. Key concept about an arithmetic sequence. All right? An arithmetic sequence with a starting value of a and a common difference d. Those are kind of important terms. Okay? So where do we start and what's the common gap or the common difference? Would look like this. A plus d, a plus 2d, a plus 3d. What would the next one be? Yeah, a plus 4d, a plus 5d. And each one of them is gapped d units apart. So that we could get the first term, a sub 1, right here. A sub 1 is called a. And then any term after that, a sub n, which we're looking at the last term, would be a sub n minus 1 plus that common difference, or d. So any term could be, if I had the 25th term, that would be 25 minus 1, or the 24th term plus the common difference, d. So we get this same pattern that we're talking about up here in a formula form. So n is the number of terms. So if it's the 5th term, n is 5. If it's the 10th term, n is 10. Okay? And an explicit definition for the sequence in the single formula looks like this. Okay? A sub n, any term, equals a, the first term, plus n minus 1. Okay? That would be the previous term. So if you're looking for a sub 10, that would be 10 minus 1, or 9. Ninth term times d plus the first term. All right? And then that would give us any term. All right? If if a D exists, this is an important thought here, if a D does exist, common difference, does exist, then it's considered an arithmetic sequence. All right? And then if it's an arithmetic sequence, the formula can be used. So if we know it's arithmetic, in other words, we know there's a common difference. All right, let's take a look at how does that work. So I have 3, 6, 9, 12, 15. Is there a term that you can add to the first term that would give me the second term, and the second term that would give me the third term, and the third term that would give me the fourth term, all the way through? Got to check them all right? If you were saying, yeah, add 3, you are correct, okay? So my D, common difference, is 3. So, is this a sequence? The answer would be yes. It's an arithmetic sequence. And the D equals 3. So this is how I know there's a common difference. And remember I said, if D exists, right here, if D does exist, then it's considered an arithmetic sequence. All right, next problem. Is this a arithmetic defect? Notice how I'm saying that. It's arithmetic, not arithmetic, okay? So the adjectival form of arithmetic is arithmetic, all right? So, and I'm not mispronouncing that. Arithmetic sequence. So I go from 1 to 3, or 1 to 4, that's an add of 3. 4 to 9, that's an add of 5. Okay, so plus 3, plus 5. Oops, those aren't the same. I can almost stop here. We'll go ahead, add 7, add 9. Hey, there's definitely a pattern here, but it's not arithmetic. So is this an arithmetic sequence? No, and no common D, or no common difference. Okay, and since we don't have a common difference, it's not arithmetic. So the answer is no. Moving on. How about the sequence 2, 4, 8, 16? Okay, well, let's see. I'd add 2, add 4, add 8. Again, nope, that one doesn't work. Okay, because no common difference. Okay, so no, it is not. We'll take a look at another one. So what would the 100th term of the arithmetic sequence that begins with, I meant to highlight that, begins with 6. So here's what it tells us, that a sub 1 begins with 6. So a sub 1, the very first term, is 6. Now, my formula, a sub n equals a sub 1 plus n minus 1 times d. So what I need to do is, I need to identify some terms here. I need to identify first the first term. Well, we just did. A sub 1 is 6. All right. Then I need to know what's the n term. Okay, well, the n is the number of the term, and this one is 100. So n is 100. Okay, it's the 100th term. All right. And then the common difference. Well, I got to look at the terms here. Now, we defined this in the very first sentence of an arithmetic sequence. So 6 to 11 would be plus 5. So my D has to be 5. Even though we only have 2 terms, we identified that it was arithmetic. So we can take the second term minus the first term, which gives us a difference, common difference of 5. Now, if I plug those numbers in to this formula, okay, let's go back to navy blue. So I would have a sub 100, that'd be the 100th term, which right now I don't have any value for yet, or value in there, is going to be 6 plus n minus 1. Well, that's going to be 100 minus 1, it's 99, times 5. Okay, so 6 plus, and we just said 99, times 5 should give us the 100th term. Okay, 99 times 5 is going to give us 495. If I add that to 6, a sub 100 would equal 501. So 501 gives us our 100th term. All right, So it starts at 6. Check it out. Starts at 6, goes to 11, and the 100th term is only going to be a 501. This didn't go crazy fast. This is very much linear. Arithmetic sequences make a line. They're in a straight line and they progress almost like with a slope. Okay? Let's take a look at another one. What are the second and third terms of the arithmetic sequence? All right, so if I've got my first term, my second term, my third term, and my fourth term, okay, I went up 1, 2, 3 bunny hops. Okay, so the first term, a sub 1, plus 3 hops, or 3 common differences, because it was called arithmetic, gives me the fourth term, a sub 4. Okay, now plug your numbers in there. So 100 plus 3d would give me 82. All right, now subtract 100. Looks like my d is going to end up being negative, and it is in this case. So I'm going to get 3d left on the left side. And what is 82 minus 100? Well, 100 minus 82 would give me 18. So 82 minus 100 would be negative 18. And then if I divide by 3, I'm going to get d equals negative 6. So d is a negative number. It's on a downward slope. All right. So we go from my first term to my second term. If a sub 1 is 100, then I'm going to add negative 6 to it, and a sub 2 would be 94. A sub 3 would add negative 6 to 94, is going to give me 88. And hopefully, a sub 4 should take us right back here to 82. 88 minus 6 does give us 82. So here's the second and third terms. All right, now what's the 46th term? And we're going to wind it up with this. Okay, the 46th term of the arithmetic sequence. We got to go through all that stuff again, though. It is arithmetic, so I am using that a sub n equals a sub 1 plus n minus 1 times d formula. And remember, the a sub 1 is the first term. Well, the first term here is 3. Okay, and my common difference, 5 minus 3 is 2, 7 minus 5 is 2, so my common difference, d, is 2. All right, we're looking for the 46th term, so in this case, n is 46. So I'm going to start plugging them in. A sub 46, there's the n, equals a sub 1. That's a 3 plus 46 again, minus 1, times 2. Well, 46 minus 1 times 2 would be 45 times 2, plus 3. That's the 46th term. So a sub 46 is going to be 3 plus 90, or 93. So that's the 46th term in this sequence. All right, we're going to stop at that point, and we will pick it up from there on for Monday's set. Hope this hasn't been too bad. You'll go along with your homework, and don't forget to check your Power School. I should have your grades back up to speed on Friday. Have a great day. Bye.